Hey y'all, the last type of ionization energy we want to briefly just look at really quickly is that of the noble gases and of stable ions. Briefly talked about those in the last video, but I want to go over them a little bit more. So remember, the noble gases are that group 18 on the very far right hand side of the periodic table. They have a full level of valence electrons already. So we said that made them very stable, which means the ionization energy values for noble gases are extremely high. They are happy the way they are. They don't want to lose or gain or anything about electrons. So that just means that a lot of energy is required to take away an electron from an atom with 8 valence electrons and full energy levels. Right? So we're looking at neon as kind of an example here, right? So here's neon. Those of you that did that things about electron configuration know there's 2 electrons in every level. Neon has 10 electrons total. So there it is right there. It is full. Every level from neon. 2 electrons in the first level, 8 in the next. It is full and happy, right? So it is very stable. Which means a huge amount of energy to remove an electron. Right? It rarely loses or gains an electron during a chemical reaction. It is very, very rare for neon to react with anything. Very stable, very inert. So, just like at the very end of the last video when we talked about those big jumps, so if an ion has an electron configuration like a noble gas, that last column, with no valence electrons, the ionization energy from that ion is also very high. We talked about that at the end of the last video. So it just requires a very large amount of energy to remove. So here we have sodium. It has a +1 charge because you can see it has got 11 protons and only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 electrons. So it's got a positive charge. It has a full energy levels. Very difficult. Here we have magnesium. It has a +2 charge, 12 protons, 10 electrons, 2 full shells, so it's very difficult to remove an electron. Here we have aluminum. It was been our example all along, right? It's got a +3 charge, 13 protons, 10 electrons, full shells. Very difficult. Because these ions are stable, incredibly difficult to remove an electron.